been talking about testing batteries and all these different components on the charging and starting system of a car. We talked about the different parts of the starter and so on. Well, how do you go about determining what's actually wrong? That can be a complicated thing, and a lot of technicians even don't fully understand the proper way to test these things. So what we have to do is what is called a voltage drop test. Now, a voltage drop test is going to tell us how much current voltage is being lost over the different components in the system. And that's going to tell us what is wrong with the system. So here we have our starting system, and this gets to be a real problem because it draws a lot of current. And people say, well, why don't you take your digital volt ohm meter and just measure resistance on these things? Well, the reason you don't do that is because in many cases, due to the high amperage draw in this system, the volt ohm meter can't read resistance small enough that it would affect this system. In other words, where in a low current system, you might be looking toward higher resistance factors and so on. Here, just a teeny little bit of resistance can make the starter sound like you have a bad battery. So how do you go about doing this? Well, first you have to realize that there's going to be a certain amount of voltage drop for various things, like 1/10 of a volt for the relay and 1/10 of a volt for the solenoid and so on. So how are you going to check this voltage drop? Well, the first thing you're going to do is that you are going to run a parallel test or a parallel circuit with the leads from your voltmeter. So in order to check the positive side of this, what you're going to do is you're going to connect one of the voltmeter leads here at the positive battery post. Not the cable, but the post. And you're going to run the other end of it down here to where it goes into the starter, like that. Now, you crank the engine to see what goes on. You look at the reading on your voltmeter, and you have to allow for 1/10 of a volt, 1/10 of a volt, and so on. So 2/10 of a volt would be allowable. Well, if it exceeds that when you turn the starter mode or turn the key to the start position, what you do next is you move this cable, take it off of here, and move it up here, like this. Now you crank it again. If the voltage drop is now within limits, you have a problem in this wire right here, or this connection. But suppose it still fails. And then what do? You move it up here. Now if it's good and wasn't before, we know that the problem is inside the solenoid. And the other thing to remember, when you take something like this that has an allowance, when you take that out, you subtract that amount from its allowance. So in other words, here originally we had 2/10 of a volt allowed. Now, because this solenoid is no longer between the two cables or test leads, we no longer have 2/10 allowed, we only have 1/10. Anyway, we go through that step by step, and we go from here over to here and then over to here. And the last thing that we take out of the circuit from between those two test leads, the last thing we take out, and it falls in specs, that last thing is the problem. So, it sounds complicated, but when you get into it and you realize what you're doing, it's pretty simple. Do the same thing over on the ground side, and here you're allowed, in most cases, 1/10 of a volt. That's it. Don't want any more than that. And also remember, when I say connect to the battery post, I mean connect to the battery post, not the cable end. Reason being is there may be high resistance between the battery post and the battery cable end. So one of the things that you're going to do is to move your test lead from the post out to the cable end. So we're going to have this cable that goes around the post. So you move it from here to here, and the reading should be exactly the same. If it isn't, well, you have too much voltage drop, then your problem is a dirty battery cable connection. That's how you go about isolating all of this. If all of this passes, if you have the proper voltage drop all the way down to here, and you have the proper voltage drop to ground, guess what? You got a bad starter. So by proving everything else is right, you prove the starter is wrong. And if you have a question, a comment, or just want a lot of great information, check us out at goss-garage.com.